Here's a question that has quietly unsettled some of the smartest people who ever lived. The universe is unimaginably vast. Our galaxy alone holds 200 billion stars, and most of them, we now know, have planets. There are perhaps 100 billion galaxies beyond our own. The numbers involved are so large that even a vanishingly small chance of life becomes, multiplied across that much space and that much time, almost a certainty somewhere. And yet, when we look up, we hear nothing. No signal, no probe, no visitor, no evidence that anyone else has ever existed at all. Given how old and how large the universe is, someone should have arrived by now. Someone should have said something. The silence itself has a name. Physicists call it the Fermi paradox, and tonight we're going to sit inside that silence for a while and consider calmly what it might mean. The story begins, appropriately, over lunch. In the summer of 1950, the physicist Enrico Fermi was eating with colleagues at Los Alamos, the laboratory where the atomic bomb had been built a few years before. The conversation drifted to flying saucers, then to the possibility of faster-than-light travel, then to the sheer number of stars in the galaxy. And in the middle of it, according to those who were there, Fermi asked a simple question that stopped the table. Where is everybody? He was not being flippant. Fermi was one of the great calculating minds of the century, a man famous for working out rough, powerful estimates from first principles. And when he ran the numbers in his head, the silence around him stopped making sense. To see why the silence is strange, you have to appreciate how much time our galaxy has had. The Milky Way is roughly 13 billion years old. A civilization does not need magic to spread across a galaxy. It only needs modest, plausible technology and patience. Send self-sufficient colony ships to the nearest stars. Let each new colony do the same a few generations later, and the wave spreads outward like ripples in a pond. Even at a fraction of the speed of light, with long pauses to settle each system, the mathematics is unforgiving. A single spacefaring civilization could cross the entire galaxy in something like 5 to 50 million years. That sounds long. It is not. 50 million years is a fraction of a single % of the galaxy's age. If intelligent life had arisen just once, early in the galaxy's history, and chosen to expand, it would have had time to do so completely, many times over, long before the Earth had even finished forming. We would not be wondering if we are alone. We would already know we were not. So either it has happened, and we somehow can't see it, or it hasn't happened at all. Both possibilities are strange enough to have generated entire fields of serious research, and tonight we'll walk through the leading explanations, in roughly the order scientists take them seriously. The gentlest explanations simply say, we are rarer than we assume. The first is called the rare Earth hypothesis, and it argues that simple life might be common, but the specific, long, uninterrupted chain of accidents required for complex, intelligent life is not. Our planet has a single, unusually large moon, which stabilizes the tilt of our axis and gives us a gentle, predictable climate over hundreds of millions of years. We have a molten iron core generating a magnetic field that deflects solar radiation. We sit at a distance from a stable, long-lived star that keeps water liquid for billions of years without much variation. We have a giant planet, Jupiter, sweeping up comets and asteroids that would otherwise strike us far more often. Any one of these could plausibly be missing on another world. All of them, together, might be a much rarer coincidence than we assume from a sample size of exactly one planet. Related to this is the Great Filter, perhaps the most sobering idea in the whole conversation, because it does not just ask why we haven't found anyone. It asks what stands between simple chemistry and a civilization capable of reaching the stars, and whether we have already passed the hardest part or whether it is still ahead of us. The filter could be behind us, perhaps the origin of life itself, the jump from simple to complex cells, or the emergence of intelligence, are each so improbable that they rarely happen twice. In that case, we are unlikely, but safely past the danger, and our future is simply open. Or the filter could be ahead of us. Perhaps civilizations reliably discover nuclear weapons, or engineered pathogens, or runaway artificial intelligence, or simply exhaust their own planet before they ever discover how to leave it. In that case, every quiet sky we see is not evidence of good luck. It is a graveyard we have not yet learned to read. A gentler set of answers says that life and even intelligence might be common, but that civilizations advanced enough to be visible from light years away are simply rare, because most intelligent species do not last very long once they acquire powerful technology. Not through some inevitable self-destruction, necessarily, but because the window between capable of building a radio telescope and capable of destroying yourself with your own tools may be short, cosmically speaking. Our own species built the ability to end civilization within decades of building the ability to listen for one. If most technological civilizations survive only a few hundred or a few thousand years before some catastrophe, self-inflicted or otherwise, narrows or ends them, then at any given moment only a handful of the galaxy's civilizations are broadcasting at all, and the odds of two of them overlapping in both time and space become very small. The galaxy could have been full of voices, just never at the same moment as ours. Then there are the answers that assume we are not actually alone, and that someone is out there. We're simply failing, for one reason or another, to notice. Perhaps interstellar travel is far harder than our optimism assumes, bound tightly by the speed of light with no shortcuts, and so civilizations remain largely confined to their own solar systems, quiet and unreachable, the way a single conversation in a vast, silent city might never reach the next building. Perhaps advanced civilizations communicate in ways we have not yet learned to detect at all. Not radio, which is a young and rather clumsy technology even for us, but something we haven't invented the instruments to notice yet. It would not be the first time humanity mistook the limits of its own instruments for the limits of reality. And then there are the stranger, more unsettling answers, the ones that suggest the silence is not an accident, but a choice. The zoo hypothesis proposes that advanced civilizations know about us and have deliberately chosen not to make contact, observing quietly the way a wildlife researcher might watch a protected species without interfering, waiting for us to mature before any introduction is made. A darker cousin of this idea, sometimes called the dark forest hypothesis, suggests the opposite kind of silence, that the galaxy is quiet not out of courtesy, but out of fear. In a universe where you cannot know a stranger's intentions, and where any signal reveals your location to whoever might be listening, the only rational strategy for survival may be to stay perfectly silent and to eliminate quickly and quietly anything that reveals itself by broadcasting. Under that theory, every civilization sits in the dark, straining to listen, terrified to speak, precisely because speaking might be the last mistake it ever makes. It is a chilling thought to have just before sleep, and also, importantly, only one hypothesis among many, with no evidence favoring it over the gentler ones. And of course, there's the simplest answer of all, the one many scientists consider still the most likely, that we are, in fact, first, or very close to it. The universe needed a first generation of massive stars to live, die, and scatter heavy elements before rocky planets like ours could even form. It took billions of years for the raw materials of life to become abundant enough, across enough of the galaxy, for the dice to be rolled very many times. It is entirely possible that intelligent life is not rare in some permanent sense, only early in a universe still young enough that most of the good rolls have not happened yet. In the truly long run, trillions of years from now, long after our sun has gone dark, the galaxy may become thick with civilizations. We may simply be some of the very first guests to arrive at a party that, cosmically speaking, has barely begun. No one knows which of these explanations is correct. It is entirely possible that several of them are true at once, each filtering out a portion of civilizations before they ever leave their home star, so that what reaches us is not one clean answer, but 100 small silences added together. What we do know is this. For as long as humans have looked up and wondered, the sky has kept its own counsel. We have listened on and off for less than a century, a single flicker against a galaxy 13 billion years old. It would be strange, perhaps even arrogant, to expect an answer so soon. The silence may not be a verdict. It may simply be that we have only just begun to ask the question properly. And there is something quietly reassuring in that thought, if you let it settle instead of unsettle you. Whatever the true answer turns out to be, whether we are rare or early, or simply too young and too quiet to be noticed yet, this small, wet, blue world is, for now, the only place we know of where anyone is asking the question at all. Every person who has ever wondered about the stars, every telescope ever built, every quiet night spent looking up has happened here on this one planet, drifting around an unremarkable star in an ordinary arm of an ordinary galaxy. That does not have to be a lonely thought. It could simply be a rare one. And rare things, as anyone who has ever loved something fragile knows, are worth taking care of. So tonight, as you drift off, let the silence outside be a gentle one rather than an empty one. Somewhere out there, the answer to Fermi's question is already written into the structure of the universe. We simply have not read it yet. Perhaps one night, decades or centuries from now, someone will. Until then, the sky keeps its secret patiently the way it has for 13 billion years, and it will keep it a little longer while you sleep. This has been the Silent Cosmos. If tonight's quiet mystery helped carry you towards sleep, there are more waiting on the channel. Rest well, under a sky that is, as far as we can tell, still keeping its oldest secret to itself.